Welcome to 52 weeks of AWS. We're on the developer certification. This is the next module, which is IAM, and I think sometimes seems boring, like users and groups, but it's really one of the most important parts of AWS. I'm going to go ahead and just get right into it and share my screen, and let's take a look at this. So to start off with IAM here, I think one of the more important things about IAM is the concept of the shared responsibility model. And so what this means is that the customer is responsible for certain parts of the system, and the developer is responsible or AWS is responsible for certain parts of the system. So AWS controls things like the hardware, the global infrastructure, the regions, availability zones, compute, storage, right? Things that are core to the actual utility. Like you can think of AWS in a sense like a utility. And then if you go into the customer, they have to be responsible for things like the actual customer data that of their customers, right? The cloud platform can't possibly know all of the different ways that the data will be used. Also, the encryption to make sure that they're actually using encryption. So, I think this is important to be aware of. And if we go down to the next section here, we can talk about an example. So let's say, for example, you wanted to use S3 for storage, and let's say Amazon workspaces for your desktop, right? This is a Windows service you can do where you can actually use the cloud itself to provision EC2 instances. And let's say you have an Oracle database inside of a VPC. AWS will protect the global infrastructure. So the physical infrastructure, they won't let people into the data center to tinker with things. But in EC2, you're responsible for managing the guest operating system, the updates, the configuration of firewall, etc. So it's really a shared responsibility. So let's talk about the identity and access management, or IAM system, in more detail here. The identity authentication is who can access a given AWS resource. And what's important about this is that this is really the heart and soul of access management. So access management is what are the resources that they can use and in what way. So even though a person has an identity, it doesn't yet mean they can do anything until they're authorized to use certain resources like read-only access to S3, for example, or write access to DynamoDB. So the big picture here is that the IAM system enables you to control access to the AWS resources, and this is through really several different components. The first one is the IAM user, and this is again the entity that is the user in the account. It represents a person, or it also could represent an application. The user has a permanent set of credentials, and that permanent set of credentials is what's controlling their interactions going forward. The group is a collection of the IAM users, and this is really a good practice. If you're going to have developers, like you'd want all the developers to have the same permission. If you're going to have operations team, the operations team should have the same privileges. You don't want to do one-off privileges. And a role is similar to a user, but it's specific in many cases to a particular instance. And the idea here is that you don't have to actually have credentials located on some system, and instead they have access only to do something on a particular instance when it's spun up. And a policy is a document that is used to explicitly list permissions to a user or to a group of users. All right, let's dive into authentication with IAM. And when you develop applications, there might be different times when authentication is required. So a good example would be you're developing a mobile app, and you have to take pictures and do some things with it to AWS. The the person that's the developer has to use their credentials to actually build the application, unless, of course, they're using something like Cloud9, where it's role-based privileges. The end user would actually need to sign into the application. This would be application authentication. And then in the final, sections here, there would need to be some kind of resource authentication. So the user would need to have the resources to upload that photo into the AWS cloud. And then finally, there has to be a way to do something like database authentication when the new row in the database is updated. So these are some really common authentication scenarios, developer, user, resource, and database. Now, to authenticate into AWS, a couple things to remember here is that in terms of the console itself, you would actually log in with your username, the password, the account ID, and also a MFA code. And this is like a two-factor authentication code. And that's really a best practice that's recommended. The other way you can authenticate is via the access key ID and the secret access key. So you would use the AWS CLI, the SDK, even the HTTPS APIs. And in that situation, you don't even necessarily need to log into the console. You could completely use programmatic access to access it. And one of the things to be aware of is that you should also avoid using the root user for either of these things. So multi-factor authentication is one of the best ways to add security best practices to your application. It adds another layer of security, and when a user signs into the console, they're going to be prompted for not only the username and password, that's the first factor, but they're also going to have a second factor. And these could be things like a phone that has a authentication device, a YubiKey, Gemalto device. You can also enforce MFA authentication by using restrictions as well. So maybe certain APIs have to be used with MFA as well. Amazon STS is a service that issues temporary security credentials, and that's another factor as well. So temporary credentials are pretty interesting because there's some times when there's trusted users that need temporary credentials to an account. And some examples would be there's an IAM user on one account that maybe needs access to a resource at another account, and the user identities were authenticated by a system outside of AWS. Maybe another one would be a mobile application is going to need access to an AWS resource. Another one would be temporary security credentials to run an application on an instance, but you don't want to run the credentials long term there. So in general, there's several scenarios for temporary credentials. So AWS has multiple ways to provide credentials that are temporary. For AWS Cloud9, for example, these are all temporary access, and these credentials are called AWS Managed Temporary Credentials. And so this is an approach for things like EC2 environment, and they will give you those credentials on the behalf of AWS. There's another one, which is you can attach an instance profile to an EC2 instance. And this is similar, but the difference is you have to create and manage the instance profile yourself. And so this would be a great for like application developers. Another one is you can store permanent credentials within EC2 or SSH. The problem with this, though, is it's a less secure approach, and it's only supported approach for an SSH environments. So how do you use credential files and credential profile? So this is a common issue, I think, for many people using AWS for the first time is they have issues with using their credentials. And one of the ways that you can get really running quickly is to use AWS configure command. And this will store your credentials typically in the tilde /.aws/credentials location on Linux, Mac, or Unix. On Windows, the default location is users username /.aws/credentials. So what's in here? There's a few different benefits. The credentials are stored outside of your project, so you don't accidentally check it into version control. You can also define multiple projects. So this is a key one actually for, let's say, people that are consultants. I've had to deal with this before where I'm consulting on 5 different projects that all use AWS. You definitely don't want to be doing something to one environment as a consultant when it was meant to be done to another environment. And this is why you create profiles for each user. Also with the AWS CLI, you can specify which profile you want to use. And so you can switch between different profiles as well. So in a general, the summary of best practices are that do use credential files, make sure you use IAM rules with temporary credentials. Don't use the root user. That's the biggest no-no. Don't put your credentials somewhere in code. That's a huge problem because eventually they'll get out. And don't put your credentials in a public place. Your account will get hacked. Okay, let's talk about authorization with IAM next here. So in terms of the policies and permissions, IAM will let you access the AWS resources through policies and permissions. And this could be like IAM group that can read, write, and delete, for example. And there's a second one that can only read the object in a bucket 2. By default, authenticated IAM user group or role can't access anything unless you actually give them permission. And the permissions are through a policy, and the policy is in JSON format or JavaScript object notation format. And they can either revoke something or they can add something. And so by default, though, the resources have to be, explicitly allowed or denied. So some of the things you can do with IAM are, again, like assigning S3 full access permissions to a group. Okay, let's talk about identity-based and resource-based. So identity-based is what you would expect, right? It's a user group or role. And so you would do things like, this person can read something, write something, and list something, but this other user can only read it, or a manager can only list things. And then in a resource-based policy, the resource, this would be who has access to a particular resource and whether a group or user has access to it. You can use resource-based policies for granting the cross-account access between 2 trusted AWS accounts. So they're a little bit different. Now, in terms of an identity-based policy, it allows a user to do specific things. So in the first section of a policy, again, which is in JSON format, there's the allowed actions, right? It'll say action, IAM login profile, for example. But then under the next section would be the resources, and the resources are what actually can be performed, right? So the actions are the actions that you'll do, and then later the resources are where they'll be done too. And so in particular, this format, once you get used to it, is fairly intuitive. And so a good example of a resource-based policy would be that who can make the request. So like, what is the actual account ID? And then what is the action? And then third, what are the actual resources that are being shared with that account? So IAM policies can be either managed or they can be inline. So a managed policy basically is a standalone or identity-based policy. And these are managed and created by AWS. So that's the big takeaway, is managed policies, like you don't have to do anything. And a lot of times these are very useful. There's a customer managed policy. The difference here is you create it and manage it yourself. The managed policy has several features that I think are nice over customer managed: reusability, central change management, versioning and rollback, and also the ability to delegate permissions to others. And then there's inline policies, which are embedded in a principal entity like a user group or role, and that's part of the entity. And you can use the same policy for multiple entities. So why would you use the inline policies? These are helpful for like a strict one-to-one relationship between a policy and an entity to which those policies apply. So here's the logic for policies. basically by default, all the requests are denied. An explicit allow will override the default deny. An explicit deny overrides an explicit allow. And so that's really the order. Step one, everything's denied. Step two, you can override if you do an explicit override. And then step three is you can always deny an explicit allow. And so the order really has no outcome. Really, it's the result of the action is what you care about. So here's an example of the logic. Basically, if DynamoDB table, you could specify the exact table, and you could say, this is the actual effect we want to allow, and then below that you could have a second section that says deny, and it could have some additional information that has additional deny information about it. So the bottom half of that would be an explicit deny, and the explicit deny ensures that the entity can't perform any action except for the ones that were specified above, right? And so that's why you would potentially combine both of them. And the explicit deny statement will take precedence over an allow statement. So when you think about using security, the thing you'll hear a lot on exams is PLP, or principle of least privilege. And in a nutshell, what it means is don't give people more access than what they need, right? Just give the permissions that are exactly what they need and stop there. If they need more, they can always come back to you and get more permissions in the future. Here's a scenario for IAM that's worth discussing. Is let's say somebody starts their own company, they want to use AWS for infrastructure, and then they open up an AWS account with the root credentials. They would not want to use those for day-to-day permissions because it's got essentially the ability to do anything. The best practice would be the next thing they do is that user would create a IAM user so that they could actually use that as their primary login. So you don't use the root account as a primary login. And then once they're able to be an admin, they would create a group for administrators, maybe add a couple other people to that group, and then they would hire maybe another person that can do specific things. And then later, you can actually set other controls like explicitly denying, other administrators from doing certain things. And again, it all those starts with the first user creating an admin role to do day-to-day tasks. Now, another thing you could do is you could also create different groups. So with different groups, the idea here would be that it would be principle of least privilege. So maybe the developers can do certain things with databases, and then the operations team can do certain things with CloudWatch. Again, it's the concept of principle of least privilege. And in the case of building out new users, you would again follow this principle of least privilege. And if you wanted to create temporary roles, you could also do that on a project by project basis. And then once they're done, you could basically delete that user or delete that group, and then those temporary privileges go away. So really, some of the best practices in a nutshell for IAM would be groups are the best way to assign permissions, right? It just makes more sense to do them in bulk. Always use the principle of least privilege. All right, so that is really it for IAM. And next week, what I'm going to cover is Amazon S3. All right, well, thank you, everybody, and I will see you next week.